Welcome to this session. In this session, we are going to find limit of function of two variables x and y. So problem one or problem. Evaluate limit as x approaches 1, y approaches 2 of the function 3x squared y divided by x squared plus y squared plus 5. Now, because this is a case whereby at least one of the two values x and y are not approaching 0, then this is just a two-step problem to make a conclusion. So first, step one, replace x equals to 1, then y equals to 2. Put x equals to 1, then y equals to 2. i.e., you write limit x approaches 1, y approaches 2, 3x squared y over x squared plus y squared plus 5 equals to limit y approaches 2 of limit x approaches 1. The function is 3x squared y, x squared plus y squared plus 5. So by direct substitution, this will give us limit y approaching 2 of, so where is x put 1, so 3, 1 squared y, 1 squared plus y squared plus 5. This will give us limit y approaching 2. So this will be 3y over y squared plus 1 plus 5 is 6. Now this is just a function of one variable. So we also replace y for 2. So it will be 3, 2, 2 squared plus 6. 3 by 2 is 6. 2 squared is 4 plus 6 is 10, which is 3 over 5. So F1 is 3 over 5. Next step, now we reverse the order. We start now by replacing y for 2, then finish with x equals to 1. Step 2, and which is the last step. Put y for 2, then x for 1. So i.e., the limit x approaching 1, y approaching 2, the function is 3x squared y, x squared plus y squared plus 5 will be limit x approaches 1, limit y approaches 2, 3x squared y over x squared plus y squared plus 5. So direct substitution will help us evaluate limit in the square bracket. So limit x approaches 1 of, so 3x squared, where this y you push to, x squared plus 2 squared plus 5, which will be limit x approaches 1 2 by 3 is 6. 2 squared is 4 plus 5 is 9. So x squared plus 9. So the problem just reduces to finding the limit of a function of a single variable x. And direct substitution should help us evaluate that. So put where this x1. So 6, 1 squared. 1 squared plus 9. 6 by 1 squared is 6. 1 squared plus 9 is 10. And this still gives us 3 over 5. So this is our F2. Now, since F1 equals to F2 equals to 3 over 5, and we were not approaching the origin, then the limit of the function f of xy exists. That is the limit as x approaches 1, y approaches 2 of the function 3x squared y divided by x squared plus y squared plus 5 is equals to 3 over 5. Problem 2. Evaluate limit x approaches infinity, y approaches 3, function is 2x minus 3, x power 3 plus 4 y cubed. So this is also still a two-step problem because we are not approaching the origin. So solution, step 1, put x approaches infinity, then y approaches 3. This will mean we write limit x approaches infinity, y approaches 3, 2x minus 3 divided by x cubed plus 4 y cubed will be limit y approaches 3, and then we calculate the limit x approaches infinity of the function 2x minus 3 over x cubed plus 4 y cubed. Now, if you remember the process of finding the limit as x approaches infinity of rational function f p of x over q of x, we simply say that you identify the x with the highest power in the denominator, and then you divide every term both in the numerator and denominator by that x. So because we are approaching infinity for x here, so the x in the denominator with the highest power is this x power 3. So the limit of this function will be the same as limit y approaches 3 of now limit x approaches infinity, but then now each term is divided by this x power 3. So we'll have 2x over x power 3 minus 3 over x power 3. So x over 3 over x power 3 is just 1 plus 4y power 3 over x power 3. Now, we can simplify further and have this equals to limit as y approaches 3. Now, this will be limit x approaches infinity. So this will be 2 over x squared minus 3 over x cubed 1 plus, this can be written as 4 into y over x cubed, and then close the brackets. Now, limit of a quotient is the same as the limit of the numerator over the limit of the denominator. So we supply limit on each of these terms. So we have limit y approaches 3 of now limit as x approaches infinity of 2 over x squared minus limit as x approaches infinity of 3 over x cubed over limit as x approaches infinity of 1 plus limit as x approaches infinity of 4 y over x power 3, which can be written as limit as y approaches 3. Now, this is the same as writing 2 limit x approaches infinity of 1 over x squared minus 3 limit 1 over x power 3 x approaches infinity, limit of 1 as x approaches infinity just 1, plus 4 limit as x approaches infinity of y over x cubed. So this will be limit as y approaches 3. As x approaches infinity, then denominator is growing larger and larger and larger. So it is reducing this fraction to a very, very small number. So this limit will be 0. So this will give us 0. Similarly, this denominator is growing larger and larger. So part of that fraction is going to 0. Similarly, x power 3 is the denominator and the value is growing larger and larger because y is fixed. So this is also 0. So we have 2 by 0 minus 3 by 0 over 1 plus 4 by 0. And that resulting fraction is defined because the denominator is not 0. Of course, we'll have 2 times 0 is 0 minus 0 is 0. So 0 over 1. So this is the limit as y approaches 3 of 0 over 1, which is just limit of 0 as y approaches 3. Limit of a constant is the same constant. So this is f1. Our next step now, step 2, which is the last step, put now yx, remember the first one you said we put x to infinity, then y to 3. So let's start now with y. So y to approaches 3, then limit x approaches infinity, y approaches 3. The function was 2x minus 3 over x cubed plus 4 y cubed. This will be limit x approaches infinity of limit y approaches 3 of the function 2x minus 3 x cubed plus 4 y cubed. So where there's y, you put 3, so that we'll have limit as x approaches infinity, 2x minus 3 x cubed plus 4, but where there's y, you put 3. So we'll have 4 times 3 power 3, 108. So this limit x approaches infinity, 2x minus 3 x cubed plus 108. And so this is just the problem of finding limit of a single variable as x approaches infinity. We simply, with this rational function, divide each term, both in the numerator and denominator, by this x power 3. So this will be limit x approaches infinity of 2x over x cubed minus 3 over x cubed over 1 plus 108 over x cubed. This is a process of finding limit as x approaches infinity of a rational function. So this will be limit as x approaches infinity of 2 over x squared minus 3 over x cubed 1 plus 108 over x cubed. A limit of quotient is the same as supplying limit both in the numerator and denominator. So this is limit as x approaches infinity of 2 over x squared minus limit as x approaches infinity 3 over x cubed, limit as x approaches infinity of 1 plus limit x approaches infinity of 108 x power 3, which is the same as factor out to limit as x approaches infinity 1 over x squared minus 3 limit 1 over x cubed x approaches infinity divided by, so this is the one limit of a constant regardless of where the value is approaching is always the same constant. And then plus 108 limit x approaches infinity of 1 over x power 3. Now, as you increase the value of the denominator, this fraction becomes smaller and smaller. So that approaches 0. This part will also be 0. Similarly, this part will be 0. So just same as 2 by 0 minus 3 by 0 divided by 1 plus 108 by 0. And on simplification, it will be 0 over 1, which is just the same as 0. So this is our F2. Now, since F1 equals to F2 equals to 0, then the limit of f of xy exists, i.e., we write limit of the function 2x minus 3 x cubed plus 4y cubed x approaches infinity, y approaches 3 is equals to 0. So that is how we solve those two problems. Thank you.